Today we are walking through Ask, Don't Judge binary questions for interpretable LLM evaluation and self-improvement.
What is the problem this paper is trying to solve?
The paper is about evaluating outputs from large language models. Human evaluation is slow and expensive. Lexical metrics miss open-ended quality. And the holistic LLM judge can give a score without telling you what actually went wrong.
So a score can be correct enough to rank outputs but still useless for fixing them.
Exactly. If a summary gets a middling score, the developer still needs to know whether the failure is factual inconsistency, missing content, weak relevance, or poor fluency. The paper's prior work gap is that earlier evaluators often hide those failure modes inside one scalar number.
What does the proposed method change in that setup?
Then evil replaces one broad judgment with many small yes or no checks. A prompt turns the task prompt into atomic binary questions. An evaluator answers each question for an output, and the answers are aggregated into dimension level and overall scores.
Can you define atomic binary question before we go further?
An atomic binary question is a narrow criterion that can be answered yes or no, such as whether a summary contradicts the source, or whether a dialogue response stays grounded. The key is that each question isolates one checkable failure mode. The question generation equation says that the set of questions comes from the task prompt in the meta prompt.
What are T and M doing in that equation?
T is the task prompt, like a summarization or instruction following requirement. M is the meta prompt that tells an LLM how to decompose that task into questions. The equation matters because then evil can adapt the checklist to the task instead of using one fixed rubric. After the questions exist, the scoring equation averages yes answers inside one evaluation dimension.
So the score is not a mysterious rating, it is the fraction of checks that passed?
Right. Fi returns 1 when the evaluator answers yes and 0 otherwise. That makes the score inspectable. If consistency is low, you can look at the specific failed consistency questions instead of guessing why the output was penalized.
How does this connect to improving prompts, not just evaluating them?
The failed binary questions become targeted feedback. In cross-model update, a target evaluator is adjusted toward a stronger source evaluator. In self-update, a generator uses evaluator identify failures to revise its own prompt. Now we can move from the method to the evidence. The first result chart compares score distributions on some evil across coherence, consistency, fluency, and relevance.
What should I compare in these some evil distributions?
Compare each method's distribution with the human distribution. Then evil with Claude is close to the human shape on several dimensions, while some baselines compress scores near the top or bottom. That matters because an evaluator needs to separate clearly flawed outputs from borderline ones. The next some evil chart groups outputs by summarization system. This checks whether an evaluator preserves the relative ordering of the systems, not just individual summary scores.
What is the strongest practical takeaway from grouping by system?
The paper argues that evil tracks system-level differences better than flatter baselines. For a developer choosing between summarization systems, that means the evaluation can support ranking decisions while still leaving behind question-level diagnoses. Topical chat tests dialogue quality, where naturalness, coherence, engagingness, and groundedness do not always move together.
Why is decomposition especially useful for dialogue here?
Dialogue quality is multidimensional. A response can sound natural but be weakly grounded, or be coherent but not engaging. The paper reports that evil with Claude best matches the human distributions overall, while uni-evil with GPTOS is nearly flat in several dimensions. The per-system topical chat chart makes the same point at the dialogue system level.
Which comparison matters most in that system level view?
The useful comparison is human ordering versus evaluator ordering. Then evil with Claude keeps more of the human-like ordering and spread, while weaker evaluators compress low and middle systems. That compression is exactly what makes an evaluator less useful for choosing what to improve. QAGS focuses on factual consistency. The paper highlights this benchmark because consistency errors are a central case where a broad score can hide the actual problem.
What does the QAGS comparison beyond the earlier charts?
It shows the same idea on a more factual benchmark. evil is designed to ask explicit consistency questions, so the evidence is not only that it correlates with human judgments, but that it gives a path back to the specific consistency checks that failed. The scatter plots compare human scores against evaluator scores onto QAGS subsets.
How should I read the scatter plots without getting lost in every point?
Look for whether the fitted line moves with the diagonal trend. A stronger evaluator should assign higher scores when humans assign higher scores. The paper reports that evil is competitive here, especially because its score is built from explicit questions rather than a single opaque judgment.
Did the question level feedback actually improve prompts?
Yes, but with an important boundary. On some evil evaluator prompt update, the paper reports average spearman improvement from 440 to 515 for self-update and from 451 to 520 for cross-model update. Consistency improves especially strongly in cross-model update, from 501 to 637.
What is the boundary?
Prompt update helps when the model has the ability but needs better instructions. On IF bench, formatting sentence constraints improved by 17 percentage points. The paper treats those as capability or instruction overload limits rather than easy prompt fixes.
What limitations should viewers keep in mind?
Then evil trades efficiency for diagnosis because it must generate and answer multiple questions. It also depends on question quality. If the question set misses an important criterion, the final score can miss it too. And averaging yes answers assumes each satisfied question contributes roughly linearly to quality.
So the main claim is not just that Benevil scores well.
That is the core takeaway. By asking many binary questions, Benevil turns evaluation into a checklist of visible decisions. The results show competitive agreement with humans on summarization, dialogue, and factual consistency, while the prompt update experiments show how those decisions can guide improvement. That wraps up this paper walkthrough.